All right, so now let's see this particular question. So in this question, we are given an integer array, and this array can contain either positive or negative integers, and it can also contain zeros, right? What we need to do is we need to find the maximum product possible that we can get in a subarray, in any subarray of this particular array, right? So essentially, we need to find the maximum product possible from any subarray of this particular array, right? And that's why we are calling it as the maximum product subarray, right? So if you see this particular example, right? So over here, if you consider the subarray starting from 6 till minus 10, the product of these three numbers or this entire subarray would be 180, right? And you won't find any subarray whose product would be greater than 180 in this particular array, right? And so 180 is going to be my maximum product, right? And that's why my output is 180 over here. So that's the problem statement entirely. Now maybe you can just pause this video and try to think of a solution. And once you're done, you can just come back and check the solution here. All right. So now to solve this particular question, let's observe one thing, right? So for example, in this particular array, had there been no negative numbers and no zeros, then this question would have been really simple, right? It would have been basically, the product of all the elements of this array, right from the starting till the end, and that would have been the maximum product, right? Because the product will always increase, right, as I am multiplying more and more positive numbers to the given product, right? So I could have just traversed from the left to the right, and every element, the current element, I would have just multiplied with the previous product, right? The product that I have till the previous element, right? And that's what I would have done at every element. I would have kept on multiplying the current element with the previous available product. And at the end of the array, I would have got the maximum product possible, which is nothing but the product of all the elements, right? But now since we have the negative numbers over here, that's where the problem is, because now my product, if I do the same exercise of just keep on multiplying the current element with the previous product till the previous index, my product can actually go up or down, right? So for example, if you see product till here is -2, right? If I go to 6, now the product will be -12. So it has gone down now, right? Now if I go to -3, now it will be -3 into -12, so it will be 36, right? So now the product has gone up, right? So the product will go up and down as I'm proceeding, from the left to the right in this particular array. And that's because I have negative numbers over here, and those negative numbers can actually make my product go up and down, right? So that's the entire crux of this particular problem, why we can't just keep on multiplying the current element with the previous available product, right? So now to solve this, let's try to approach this in a trivial way, right? So let's try to find out, let me just actually write over here. My objective is to find the maximum current product which can be achieved by including the current element in that particular product, right? Essentially, my objective is to get the maximum possible product subarray with the current element a part of that particular subarray, right? That's what my objective is at every element as I'm traversing from the left to the right in this particular array, right? So if I try to do that, so once I'm at -2, the only possibility that I have is -2 over here, right? There is no other possibility that I have because I just have one element over here, right? So at -2, my current max would be -2, of course, right? Now when I go to 6, now if you see over here, I have two possibilities, right? One is that I just multiply this 6 with -2. And what is -2? -2 was actually the current maximum product till this particular point, right? If I include this particular element in my maximum product, then that would have been the current max at this particular point. And so my option is that I can just multiply 6 with the current max at this particular point, right? Which will give me -12, right? Or my other option is that I don't multiply 6 with the previous current max, but I just start a new subarray from here, right? And if I start a new subarray from here, the maximum product possible would be this number itself, because I'm starting the subarray from here. So this is the only number essentially that I have in the new subarray, right? So the second option is that I just consider this number itself as my current max product if I have to include this number in that particular product. Or the other option is that I multiply this current number with the previous available current max at the previous index, basically, right? Those are my two options. Now, how will I select that? So that's pretty simple. I will just select the maximum value of these two, right? So essentially what I will do is I will select the currently available current max, right? Which is, essentially whatever I had at my previous index. So that current max into the current element, right? Either this or the current element itself, right? Whichever is maximum, that's what I'm going to now assign to my current max at this particular index, right? Because that is the only two possibilities I have essentially right now, right? Now what I will do is, now when I move to the -3, the next element that is, now again I have two options. One is that I make this -3 a part of the subarray that I started over here, right? Or I like start a completely new subarray from -3, right? So in that case also, again, I will do the same thing. I will take the maximum of, the current element into the current max till the previous element, right? And the current element itself, right? So between these two, current element and current element into current max, I will take the maximum value and that I will assign as the current max value at this particular index, right? Which would again mean that this is that maximum product value which I can get by including -3 in that particular product, right? So this is what it means, and this is what I can keep doing at every point, right? So now let's try to kind of trace this starting from the first till the last or till, further indexes. So for example, if I start at -2, my current max would be -2 itself, right? Now what I will do is I will move to the next element, and when I come at 6, now my current max would be 6, right? Because 6 into current max, which is -2, would be -12, right? And current element is 6, so maximum among those two is 6, right? So current max will now be turned into, from -2, it will change to 6 now, right? Now when I move to -3, now what will happen is that again I will check whether -3 into 6 is greater or -3 is greater. So -3 into 6 will be -18, and current element is -3. So of course -3 is greater. So current max at this particular position now will be -3, right? So now what I'm saying is the maximum product possible, with this particular element in that particular product is -3, right? That's what I'm saying now. But now if you see these three elements, do you really think is that the correct statement, right? Is that the really current value of the maximum product possible with this particular element in it? No, right? Because now if you see these three elements, the maximum product that I get from -2 into 6 into -3 is actually 36, right? Which is much larger than -3, right? But we are getting -3 over here if we keep following this particular, method over here, right? So where did we do a miss, right? What are we missing over here? So essentially, you know, over here, we actually discarded this -2 into 6 product because it was lesser than the current element at this particular index at that point in time. So we thought that since, we are getting the maximum product at this particular index as 6, we should completely discard, -2 into 6, that is -12, and we got rid of this -2, right? But eventually, once we would have reached over here till -3, and if we had that particular product in our maximum product, then this -2 into 6 -12 would have got turned into 36, right? A positive number if I had multiplied this negative number with it, right? So the idea is that if I would have maintained, this product also, like whichever I found was lesser at that point in time, if I had maintained that particular product also as the minimum product possible with, this particular element in it, right? I would have actually got a larger number at this particular point in time, which would have become my current max product, right, at this particular index, right? So essentially what I need to do is, in addition to maintaining the current maximum product at every index, right, I also need to include, or I also need to maintain the current minimum product, possible at every index, right? And the meaning of that current minimum would be essentially that this is the minimum product by including this current element in that particular product, right? So I have to actually maintain both of them, right? Because it might so happen that once I'm traversing the entire array, I might get, a negative number. And by multiplying that current min that I have with that negative number, it might actually give me a larger positive number, which would become my new current maximum product, right? So instead of just maintaining a current max, I will be maintaining a current min also over here, right? And I will be going by the same logic, but just in a reverse way, right? So over here, my current minimum would be -2, right? Now, once I reach over here, my current min would be 6 into -2, that will be -12, right? Why? Because I am now going to take minimum of, you know, current minimum till the previous element into the current element itself, right? And the current element, right? So I'm going to keep checking, whichever is minimum between these two, and that is what I'm going to assign to the current min at every index, right? So at this index, I got the maximum as 6 and minimum was -12. So current minimum will become -12 at this index, right? And now when I'm coming at -3 now, right? So now I'm saying that my current maximum over here is 6, right? Current minimum over here is 6, right? And now when I come to -3, what will happen is that I will again recalculate my current max using this particular formula. And according to this formula, I will get current max, which is 6 at this particular position. So it will be 6 into -3, 18. And this array of I is anyways -3. So again, I will get -3 as my output. But now, in addition to checking these two, I will also check this current min into array of I, right? Because I have to check if multiplying my current min with the current element gives me a larger number or not at any point in time. And this might possibly be larger than these two, and that might become my new current max at this particular element, at this particular index, right? So that's why I will take maximum of from these three now, right? And also the opposite can also happen, that the current max at any point in time can actually become my current minimum at the next index if again I encounter a negative number, the same case. So that's why to calculate my current min also at any point in time, I will have to consider my current max also till the previous element, right? So that's why I will just check if my current max into current element itself gives me the minimum value from these three numbers, right? And that I will assign back to my current min at the current index, right? So that's what I'm going to do at every index. And see, as I'm traversing this particular array, as we know, we are going to calculate the current max at every index. So this current max is actually telling me that, at this particular index, if I actually include my current element, this is the maximum product that I can get, right? So at every index, what I will keep doing is I will keep checking if this current max product that I got at the current index by including the current element in that product, is this the maximum product that I have seen so far or not, right? That's why I will just keep a track of the maximum product that I have seen so far, and I will at every index keep taking the maximum between the max product and the current max that I calculated at the respective index, right? Like this, and I will keep reassigning my max product, right? So this is how I am going to proceed. And once I have traversed the entire array, once I have done this for all the elements of this particular array, whatever would be the value in the max underscore product variable, that would be my final output. That would be the maximum product possible from any subarray of this particular array, right? So I hope you understood now. And now let's jump to our IDE and code this particular solution. All right, so now let's implement the solution that we discussed. So to start with, let me just declare a function over here. I will just call it as max product. It will accept an integer array. And to start with, I will just capture the length of this particular array in a variable n, right? And then I will declare my current min variable, right? Which will basically hold the current minimum product at the current element, right? When I'm traversing all the elements, right? So that I will just initialize with the first element of the array, right? And then what I will do is I will declare another variable to hold the current maximum product at the current element, right? So this will be the maximum product at the current element only, right? And that also I will initialize to the first element of the array, right? And then finally what I will do is I will declare a variable to hold the maximum product that I have seen so far, right? And this also I will just initialize to 0th index basically, right? So that's what I'm doing over here. And now I can do a for loop from the first index till the last index like this, right? And now what I need to do is I need to actually calculate my current maximum and the current minimum, and then also update my maximum product that I've seen so far, right? Now what I can do is I can just calculate my current maximum like this. I can take the maximum of the current element, right? Or my current max that I had till the previous element, right? The current max product from the previous element, that into the current element, right? Or it could also be the current minimum from the previous element into the current element, right? Even this could give me a maximum product, right? If this current minimum is negative and this array of I is also negative, it might actually give me a large positive number, which is even larger than the current maximum till the last element, right? So that's why I'm doing this, considering the current min also. And now what I will do is I will just assign it into a temp variable. So why a temp variable? Because see, I also, to find the current minimum at this particular index, I will have to use the current max variable, the original value of the current max uh, variable, before actually updating it, right? So that's why I'm just holding this particular current max that I found from here in a temp variable. And now what I will do is I will find the current minimum, right? And to find the current min, I will take the minimum value from the current element, right? Like this. Again, current max into array of I, right? Or it could be simply current min into array of I, right? So these three are the possibilities, the candidates which could actually give me the current minimum product at this particular element, right? So that's what I will do. And then after I have calculated the current min, now what I can do is I can just reassign my current max, the actual current max variable, to temp, right? Because temp holds the new current max that I calculated over here, right? And then finally, if this is my current max product at this particular element, now I will just update my maximum product that I have seen so far with the greater of the current max, or the value that the maximum product variable already holds, right? Like this. So this is what I'm going to do simply. And at the end of the entire traversal of the entire array, basically, I will, this particular variable max underscore prod will have the the maximum product that is possible from this particular given input array, right? So that is what I'm going to return at the end of the for loop. So I will just return the max product like this, right? And this will be my final output, right? Now what I can do is I can just test this particular code by using the same test case that we saw earlier. I will just copy it from here like this. And now I can just print the output of this particular function max product over this particular input array, right? And it should give me 180 because this is the same example. So the output will be 180 corresponding to these three elements. Now if I run this, I get 180, right? So this is the correct output, and this is the entire solution for this particular problem, right? So this was a very good problem. This was a little tricky one. You had to think out of the box to solve this particular question. But see, these are patterns, right? So if you really, understand these patterns, why we are doing this, try to get into the why rather than the what, right? So what is something that you can essentially see either from a YouTube video anytime or a tutorial over text or anything, right? But why is something that will actually help you to solve other problems as well that might use the same concept in a way, right? So just try to understand how we were actually able to solve this particular question by this particular method of taking current min and current max at every element, right? So that's the entire solution, and now I will see you in the next video. Thank you.